talk about 3D printed replica eggs, a new 3D printer, and a 3D printed satellite with a partially 3D printed satellite with polymer 3D printed components, which is quite new. So the first thing we're going to be talking about is the New Zealand Department of Conservation, and the New Zealand Department of Conservation has been using 3D printed eggs, replica eggs. These eggs have been hand painted but 3D printed, and they are the eggs of the critically endangered tara iti, or fairy tern. Fairy tern is a coastal living bird. There's only 42 known individuals of this bird. Some of the sources say 40 across 5 sites in New Zealand. There's other variants that are less endangered, but the specific New Zealand one is completely endangered bird species. And with 42 individuals, it's very, very critical, of course, for them to be able to survive. And what they do now is all these birds, they kind of have they live on kind of rocky, hard, kind of beachy areas, and they kind of lay their eggs in a quite exposed kind of place. So what they do is they take the real eggs, take these eggs to Auckland and put them in incubators to spare them the risk of being out there in the rain and the sun and storms and predators potentially as well. And then they replace that real egg with a 3D printed egg. The bird then sits on it and continues to incubate that egg. And then later on, they replace that egg with the real one. What they've done now is there's a guy called Shaun Lee, who's in a great position, by the way. He's like the bird 3D printing guy of New Zealand, because previously he made replicas eggs for a museum exhibit. He made replica versions of these birds for also in a museum exhibit, and he's doing a bunch of stuff at the intersection of 3D printing and conservation. It's a wonderful thing, I think, that you could do locally as well. If you're into conservation and nature and stuff like that, this guy has managed to create a wonderful niche for himself in New Zealand, and he's like the go-to conservation animal life matters for if they need something 3D printed or replicated. So it's a wonderful niche for you to do yourself, perhaps in your own environment, by working with local aid societies or conservationists and stuff to do that. If you're into that, I think it's a really wonderful niche. So anyway, he did the 3D printing part of that. And Carina Sim-Smith, who's a biologist and artist, wonderful combination, is the one that hand painted them to look exactly like the real eggs. Now, this is also super successful. They've apparently had 22 eggs laid, and out of that, 14 chicks have hatched. So that could perhaps go a ways in helping that species survive. So I don't know if this is something that can be replicated somewhere else. We know that for conservation, people are using 3D printing more often, and I think this is a wonderful story of what can be done with the technology if you just put your mind to it. And also, just combine it with hand painting. We don't have to make the final object. We can just make the shape, and somebody else who's artist, especially a biologist come artist, would be a fantastic, of course, culmination to augment that and make it real. So I think wonderful kind of good news story. The other one is from Sidus Spaces. Sidus Spaces is a company that makes, wants to do kind of data as a service. They want to launch their own sensor network across the world, their own constellation, and they want to rent that out so you can then, as a gas company, search for certain things across the network, do certain data, do certain queries, kind of basically a constellation for sensors. And what they've done is something really unique for us. They've used Markforged 3D printers. Now, before this, on small Pico, nanosats and stuff like that, so small components have been printed, and people have been looking at printing the bus. And what they've done is they've done this. They've used the flame retardant Onyx FRA material, which I actually have at my house, right, to make this bus structure. And that means that I could literally 3D print a satellite component with the Markforged 3D printer I have in my house. So that's actually really cool. And that polymer flame retardant, which is good and is strong enough apparently to be used as bus construction. And what Sidus says is it allows them to save weight, obviously save time and money, and that's really critical because they want to be able to make these satellites in a kind of more automated way in like 45 days. And all these satellite component companies have the same thing. They generally have a lot of investor interest. They may actually have contracts. Of course, these guys need to get that network functioning. If they only have 5 satellites in the air, they don't have much of a constellation, right? They might need, I don't know exactly how many, but they may need hundreds of satellites until they complete that network or get halfway there. The value of that network is going to be very low. So they would just have to really get going on producing all these satellites. So these guys will turn to 3D printing if we can give them an advantage. And we're seeing that again and again on antenna components where, time is critical, engines, in-propulsion space engines, all this kind of stuff. These guys are turning to additive to solve their problems. And yeah, Sidus apparently is using polymer, which is kind of new. We knew that some platforms are using 3D printed polymer components. It's nice to see more of that out in the open and to see that there's an opportunity for polymer 3D printing in space as well. And I think that literally satellites is one of the biggest applications that are out there. The next thing is the QIDI Tech Q1 Pro. Now, this is one another data point that the desktop 3D printing market is going to be a slaughter, an all-out slaughter. We all know that Bamboo Labs put a bunch of, the A1 for a couple $100 and the P1 next one, whatever they're called, for around $1,000. They put some really, really capable, very, very fast printers out there. They're not perfect, but they really have raised the bar for a lot of 3D printing innovation. And they've really made a lot of people work harder. Like Creality's came up with some more ambitious models. And now QIDI is doing the same thing. This is a $500 printer, ladies and gentlemen. Core XY, dual independent lead screws on both of the Z stages. That should give them a little, if they coordinate that well, that should give them really good stability. There's a heated chamber up to 60 C. There's dual sensors for auto leveling. There's a runout sensor. There's even a tangling sensor. There's an internal camera, dual nozzles. Max nozzle tip is 350 C. This is 245 by 245 by 245 millimeter build volume printer. And it's available right now. You can order it, and you can get it in March, April, May, depending on where in the world you are. And, this means that you can now print nylon, PA materials, polyamide materials on a $500 machine. Now, I don't know how good this works, but the ambition level here at a $500 machine with this 350 nozzle temperature, 60-degree internal heated chamber, which can, also, I don't know if the nylon will work really well on this. What I do know is that this will make ABS and ASA parts come out really, really nicely and should really put the level much higher what people will expect with a $500 printer. I am really enthusiastic about this. And I really think that, people were talking before, the desktop 3D printing revolution, way too early. Now we're 10 years later, 10 years of more maturity. Now imagine this QIDI 2-3 years from now. It's refined a little bit. Maybe it's become more stable. Maybe it's become even cheaper. I don't even know if that's possible. It's become easier to use. The software has become better. Imagine the Bamboo Lab printers 2-3 years from now, right? A little bit more mature, a little bit, more refined, maybe cheaper. We're getting really close to consumer level. We should know, of course, that 3D modeling is not easy. 3D scanning isn't easy. What are people going to do with their 3D printers? There's several million people that buy a 3D printer every year. They're either hobbyists, DIY people, model builders, game enthusiasts, design enthusiasts, gardening enthusiasts, people that have like a particular need for like hardware things, and usually have a hardware background or the willingness to put in the 1,000 hours to learn CAD to really own this technology. Now, what does that mean for going forward? Are we going to be able to find more of those people, or are we going to be able to radically change these tools? Well, I don't know. But in terms of 3D printers, last 10 years, last 15 years has been incredible. For the desktop printers, and in terms of the specs we're getting off this thing. Now, again, I haven't tested it. I don't know if it works well. But just the specs of this thing compared to a couple of years ago when it was just like $200 MK3 knockoffs, and then some of them were $187 and somewhere $170. They're basically all the same printer. This is just an amazing leap forward, and I cannot even begin to think where we'll be like 5-10 years from now. I think it's really fantastic. And but hey, for the players out there, the company is functioning in this $500 to $2,500 desktop FDM printer space. This is going to be a bloodbath, kids. It's going to be really, really crazy. So, but for the user, I think this is going to be absolutely wonderful. Anyway, my name is Joris Spiels. I hope you found this very, very useful. Let me know if I should cover something, not cover something, or talk about a particular subject. You have a great day.